I'm showing a human circulatory system because this is the one that most of us are very familiar with. So think about what has to happen for a human circulatory system to work. You have to have blood vessels, and the heart all working together. And they they can't just evolve separately, they have to work together. And what good would it do to evolve blood vessels throughout a system without blood? And what good would it do to have blood without the blood vessels? What good would it do to have a big bulging thing in your chest without all of these systems in place? These are things that need to be planned out and coordinated. And you don't have millions of years for this. If you don't have a working circulatory system, then the organism dies. Right now, if your blood is not able to deliver the nutrients to all the cells in your body, you're going to die within minutes. So to think that this is something that can come together by natural processes over time is very naive. Now, think about it's not just the blood vessels and the heart and the blood that has to work together. Your circulatory system is integrated with all the other systems in your body. It has to work in harmony, interdependently with your respiratory system, your digestive system, your endocrine system, your urinary system, your immune system. All of these things are integrated. Think about what a compact space you have all of these systems working in. That is something that requires planning and foresight. Now, some people are satisfied with evolutionary explanations of, oh, you see, but that came about. See, it didn't start that way. It started out so simply. And if you're believing that, you're believing an evolutionary story. Look at this, even just hemoglobin. These are the steps required in order to get hemoglobin. You're probably not going to be able to read all these, and I'm not going to read all these, but Google it. Look at all the steps required just to get hemoglobin. And then if you're satisfied with, oh, but you know, the simplest life forms, look at their, it started so simply. Well, look at the cross section of this worm. Okay, although the worm is small, when you look inside, it's incredibly complex. It has a complex integrated system already in place. We do not have the development of the circulatory system over time. Now, some people have said, oh, but you're not using peer-reviewed paper. Well, here we go. We're going to look at this paper. It's the Evolutionary Origins of the Blood Vascular System and Endothelium. And so, by the way, some of the best evidence against evolution is in papers like this. So this paper goes through, it shows several different circulatory systems and describes them. And here it's showing the worm, and it tells the features of this, that it's a closed circulatory system. So, and it, you know, basically it does all of the things of transporting oxygen, nutrients, and waste, just like a human circulatory system transports and delivers the nutrients and gets rid of the waste. And here's one for a lobster. And this is a different one because it's an open system. Okay. And so it's a little bit different, but also quite complex. And then we're going to just look at a few things. Now, if you want to print this out, you can get there's a link in the description of this video. You can read along if you want to read the whole thing. I only just picked out a few parts that I thought were interesting. And what I hope that people will do is, when you're looking at things about evolution, start paying attention to the difference between science and storytelling, because papers like this are rife with storytelling. So there's lots more storytelling that I didn't highlight in pink, but the parts I'm going to read, I highlighted in pink, and the real science I highlighted in green. Okay. So in the abstract, it says existing evidence suggests that the blood vascular system first appeared in an ancestor of the triploblasts over 600 million years ago. Okay, now where do they get this idea? We're going to find out as the paper goes on. Do they actually have evidence for this, or is this just part of their storytelling? Let's find out. Well, here we go in the introduction. And here's where we get the difference between real science and evolutionary storytelling. Starts out, every biological trait requires both a proximate and an evolutionary explanation. Proximate explanations, how, employ traditional tools, including biochemistry, molecular biology, and cell biology to describe the anatomy, physiology, and ontology of a trait at the level of a modern day organism. Okay, I'm going to stop right there because that is what real science is. And so many people ask me, well, if evolution isn't true, then what's going on? Like, are you saying like no science is good or that all scientists are wrong? No, I'm saying scientists are working in spite of evolution because most science does not require evolution. Now, it might have evolutionary ideas running in the background, but there are many evolution believing scientists that are just doing good science, and this is the things that they are focused on, things that have real world applications. Now, here's where the evolutionary storytelling begins. Evolutionary explanations, when and why, employ a combination of the fossil record and comparative morphology and DNA sequences to describe the phylogenetic history of a trait and the fitness advantage that trait provides at the level of a population or species. So they start with the assumption that evolution is true, and then they try to figure out how it happened with the fossil record, comparing morphology and comparing DNA. Okay, but remember that they're starting with that assumption. So they're going to be telling stories about how things happened based on that assumption. So they said and this is interesting. So there is no trace of the cardiovascular system in the fossil record. So the cardiovascular system, soft tissue, not really well preserved, although this paper was written like 12 years ago. And I think since then we did discover like some remnants of a heart or something in a creature called Fushanwea. I don't know, you can look it up, but so I just wanted to state that this is not the most up to date, but basically this is saying like, they're not looking at cardiovascular systems in the fossil record, right? Instead, what they're doing is they're using phylogenetic analyses based on what is alive and working today to try to reconstruct a story from the past. And it says that right here. By contrast, comparative biology provides a rich source of information that can be used to infer and reconstruct the evolutionary history of the cardiovascular system. This is all assuming that this happened, okay? So, but what if you recognize that an integrated system of a worm is not something that can come about by natural processes? Well, then you're labeled anti-science. No, that is according to our scientific observations. We do not see integrated systems coming about by natural processes, but they want to infer from the past. So let's see if they can pull off any evidence or if we're going to run into a lot of problems here. So it says, as we survey the present landscape of body plans, we find a wide variety of blood vascular systems. Some are closed, others are open. Some use hearts to propel blood, while others employ pulsatile blood vessels. Only a minority are lined by endothelium. Okay, so that's just a description of reality. Great, no problem with that. Real science. But then here we get into the pink evolutionary storytelling. The answer, okay, so when and how did all of these diverse structures evolve? The answer is likely through a combination of homology and convergence. I love this because they're stating up front that their phylogenetic tree does not work. Okay, what do they mean when they say homology and convergence? They mean, well, we see homology, similarities in organisms, but then we also see organisms that are on different branches that are evolving the same structures that are already incredibly improbable to the point of being impossible to evolve once in the first place. Now they want us to believe that this happened multiple times, and we're going to get to a specific example of that mentioned in the paper here. So, the last common ancestor of vertebrates and annelids, or of vertebrates and mollusks, was the ancestor of the protostome, deuterostome ancestor, which lived between 600 and 700 million years ago. Although the fossil record is scarce, it is widely believed that this precursor animal was a segmented bilaterian. Okay, so it is believed. This is what they are putting together as their story, and they want you to believe it. So far, no evidence has been given for this at all. This is all storytelling so far. Okay, so over the past 600 to 700 million years of evolution, the blood vascular system has undergone significant modifications in response to selective pressures experienced by individual phyla. In some cases, the blood vascular system has regressed. In other words, their phylogenetic tree is all over the place. They've got circulatory systems that look different in all these different branches, and they really don't have a way to put it together in a way that makes sense. But look how they are already told us that although the fossil record is scarce, now they're telling us basically that they're trying to get us to accept that the blood vascular system has undergone significant modifications in response to selective pressures. How do we know this? We don't know this. There's no evidence for this. This has to be believed if you already accept the story of common ancestry. So there's no evidence being presented here that would cause us to accept this. It's just storytelling. Okay, so continuing on. Now, this is really interesting. The open system, because there's the open circulatory systems and the closed system, they're saying the open system reverted back to a closed design in an ancestral cephalopod. This is an example of convergent evolution. Now, this is really interesting because if we look at the octopus circulatory system, so unlike most mollusks, it has a closed circulatory system. Most mollusks have an open circulatory system. Now, evolving a circulatory system in the first place is not, I would say it's so improbable as to be impossible. But now you've got, you're saying the mollusks, they have these open circulatory systems, but the octopus wanted to basically go back to the closed circulatory system. So it's different. In other words, it doesn't fit in with the tree. The morphological similarities that should be present if this is one family tree are not present with the circulatory system with the octopus. And the octopus has 3 hearts. Most mollusks only have 1 heart. Octopus has blue hemocyanin. And by the way, blood is another issue because they also say that blood convergently evolved 7 times. And why do they say that? Because blood is so structurally different in so many organisms that it doesn't really match up. So blood is already an extremely complicated, difficult thing to get in the first place. But now you've got to get it to arise 7 times by natural processes. So the story is getting ridiculous. Now, you can go and read the entire paper if you want. It's 33 pages long, and it's mostly pink evolutionary storytelling. So have fun with that. But I just wanted to point out in their conclusion, here's their conclusion, an important take-home message is that cardiovascular systems are highly diverse in their structure and function. Okay. The design, what? Designing requires a designer. Why are they using the word design? Why? This isn't design. This is all by natural processes. Why are we pointing to design? Well, oh, they couldn't find a different word. Why not? Is it because this is obviously a design? So the design of a given system is exquisitely matched to the needs of the animal. Woo! It's not helpful to think of one system as being superior to another. Thank you. Yes. So you can't look at a worm and say, oh, see, the worm, its circulatory system is so simple. And that's how the circulatory system slowly evolved over time. No, it's not that one circulatory system is superior to another. These are all, whatever organism, these are all complex integrated systems that require planning and foresight, that don't just come about by mutations and natural selection. Okay, zero evidence has been given in this entire paper. You can go check it yourself. Zero evidence has been given for the evolutionary origins of the circulatory system. Okay, so this is just something, this is a perfect example of how people are starting with the assumption of evolution by a common ancestor, and then they don't even bother providing evidence because, hey, everybody knows it happened. All we have to do is figure out the story, and then they proceed to do storytelling. Let no other try.